reminder here as well. Let me get rid of this. If I see something like this, 3/5 times 5x minus 20 plus 7, what type of graph is that? This is linear. And if it is linear, then we're not going to use transformations to graph it, right? Because this one would be a nightmare. In fact, I haven't even really told you what to do whenever you have the 5 and the 20 here. You have to like factor it out, and I just usually don't even give that to you whenever we're doing these types of problems. But it would be a nightmare to try to do everything that you could do with this. So whenever we're graphing linear, what do? Y equals mx plus b. So if we have this problem, we are just going to distribute, and so f of x will equal 3/5 times 5, right? It's like 5/1, just cancels the 5, so we get 3x minus 3/5 times that negative 20. I can reduce here, make that a 4. I'm going to get a negative 12, so I have minus 12 plus 7. And so that's going to give me 3x minus 5. Are we okay here? All right, so we have a y-intercept at negative 5. We have a slope of 3, so we'll go up 3/1. And we'll get this graph right here. So I know I can't remember if I took the sort of W-looking problem off of the quiz or not. I might have taken it off. But I know I did not take this linear problem off. It is definitely still on the quiz. So you will see one similar to this. And remember, this is the one that I said there's extra credit for. If everybody in the whole class gets the linear problem right, then I'll give everybody 10 extra points. So if everybody gets the linear problem right, I will give 10 extra points. So be on the lookout for it. Okay. Any questions? Alrighty. Okay, so we're going to do features of functions today. So we've already done this with our exponentials and our logarithms. So it's some of your favorites. Sometimes this is less popular here. I'll be honest, it's not really my favorite. I would rather like solve stuff than do this, but we need to know how to do this. It shows up in lots of different types of math classes. So domain, just a quick overview of what we have for each one of these. So our domain is going to be our possible x values. Range is our possible y values. Okay, looking at a graph, how can we tell a function is positive? It is above the x-axis. Remember to, I'm typing some faster than it does. And so negative is below the x-axis. And then increasing would be that our y values are getting bigger from left to right. And I'm just using that not so mathematical term, getting bigger, to avoid using the word increasing when I define increasing.
Domain. That's your X's, right?
That is.
You know where all my X's are?
I do.
Texas.
I figured.
You know, place in Texas, Dallas. It starts with a D and that starts with a D.
That's right. You were telling me that the other day. This is how we'll remember it.
Because all my X's live in Texas.
All of my exes live in Texas. Dallas is in Texas. It starts with a D, so domain is possible X values.
Yeah.
Totally logical. You'll remember that really easily, right, guys?
And the Rangers play in New York.
Which has Y in it.
Yeah. Oh, my.
That's a great song. Well, Henry still kind of likes to sing it now. Hunter's too cool for anything. But when Hunter was little, he really used to love to sing All My Exes Live in Texas. So cute. He used to be so cute. Alright. And decreasing is getting smaller from left to right. I could use the phrase increasing instead of getting bigger, or decreasing instead of getting smaller. It just seems kind of wrong to use the word in the definition of the word. So there's some words that are very hard to define without using the word itself. Okay, so these are the things we're going to be looking at. We are primarily going to be looking at square root functions and rational functions. I'm going to throw in a couple others, so we'll do a little review on some domain. But these are the ones primarily we're going to be looking at because a lot of our polynomial functions are covered in Math 3, polynomials being things like quadratics and cubics and things to the 4th and 5th and 6th power. So in pre-cal, we are supposed to have extra emphasis on exponential and linear, which we've already done, and then also square root and rational functions. So those are the ones we're supposed to focus more on. You may still see some of the others, but they're going to be our main focus. So, square root functions. Okay. So with a square root, there is a specific thing that we know about square roots that is going to help us find our domain. And that is that we cannot take the square root of a negative number, right? If we try to take the square root of a negative number, we get that pesky I, and you can't graph an I on the coordinate plane. So as far as domain goes, we cannot put anything in here that would give us a negative under the square root. So even without the graph, for a square root, we can take whatever is underneath the square root, x plus 4, and say that it has to be greater than or equal to 0. Okay, you want to include the or equal to because the square root of 0 is 0. So you can take the square root of 0. You just can't take the square root of a negative number. So if I moved my 4 over here for this problem, x must be greater than or equal to negative 4. So you can write it like that, x is greater than or equal to negative 4, or you're going to see it written a lot of times with interval notation. And if we do interval notation, we would use a bracket for our negative 4, comma, infinity. We have not used any brackets yet. The reason we have not really used any bracket, well, we've not really used any brackets yet, is because with exponentials and linears, we have vertical and horizontal asymptotes, so which means we don't actually ever get to that value. But with the quadratic, that point right there is included, so you need to use a bracket when you're talking about that point. Okay, so square roots, whatever is under the square root is always got to be greater than or equal to 0. This You can also see from the graph, we can see right here we got -4. Oh, I think these dark lines right here, they're my lines. So it looked like the axis there for a minute. So if we kind of think along there, over here we've got nothing until we get to -4. Now we've got a point on our graph, and if we continue on, we're going to have a point on the graph for the rest of the time. So domain x is greater than or equal to -4. Our range, okay? Our range is our possible y values. So if I look at the graph here, I can see that right here is my very lowest y coordinate on this graph, right? And it is at -2. Everywhere up from here, I'm going to have something, even up here, it looks like I don't have a graph, but this graph is going to continue climbing, although kind of slowly, until eventually it's going to hit that line, right, no matter how high it is. So, for this, -2 is my very lowest value. So, with interval notation, I would say -2, and I would use a bracket because we do include that point, and it would go up to infinity. Or I could say x is greater than or equal to -2. Now, I'm typically going to give you either a picture of the graph or allow you to use Desmos. Definitely on range problems. Domain for square root, I could give that to you without the graph because I want you to know that whatever's under the square root has to be greater than or equal to 0. But if you're thinking about this without the graph, if we think about what's going to change our range, typically our parent function looks like this right here. If I move that left or right, it's not going to change that bottom value, right? If I move it, if I stretch it or shrink it, either way, it's not going to change that point right there because that point right there is 0, 0. So even if you stretch it or shrink it, either way, it's still going to be 0, 0. So stretches, shrinks, and horizontal translations do nothing to your range. It's only if you move the point, the graph up or down. So you can see this graph was moved down 2, and so our range was now -2 instead of just being 0 there. So that can also help you with your equations. All right, so we're now looking for where we're positive. So we want to know where we're above the x-axis. Above the x-axis is going to happen right here. Remember, you are using x values to describe this. So that happens right there at 0 and beyond. So you would either say that x is greater than zero or 0 to infinity. Now, I did not use a bracket there. Why did I not use a bracket? Very good, Connor. 0 is not positive or negative, so you don't want to include that endpoint because at that endpoint, your y-coordinate is 0, right? So when you have positive or negative, it doesn't matter what type of function you're looking at, always use parentheses for positive and negative. Because at that point, actually that's not entirely true. I take it back. Almost always. There is one case where we are going to use. Did I give you guys one of those? I don't think I gave you one here. There is one case where we'd use a bracket. The time that we would use a bracket is if we had maybe a square root that started up here, something like this. So this would always be positive, right? It's never negative at all. And this end point is positive here. So if you had something like this, you would use a bracket. You'd say 3 to infinity for that. But that would only be if the whole entire function is positive. So it can happen. But most of any other time, unless the whole thing is positive everywhere, you're going to use parentheses with that for positive and negative. All right, our negative is going to be here. Actually, you do use a bracket here. I really shouldn't have said that you always use parentheses. At that point where it crosses the x-axis, that's what I should have said. At the point where it crosses the x-axis, you need to use a parentheses there. You might need to use brackets on the ends, which we'll have to do here. So if I'm looking at what's happening here, this function is negative from where it starts, which is at -4, up to 0 right here. So I'm thinking x coordinates. So if I'm going to write that with inequality notation, it'll look like this. -4 is less than or equal to x less than 0. I'm including -4 because that is the end point where the graph ends, right? So it has a negative y coordinate, so we include it. I do not include the 0 because at that 0, that's where I cross the x-axis. I'm not positive or negative because I equals 0. So with interval notation, it would look like this: -4, 0, parentheses with that 0. Okay. Square root functions are going to either always be increasing or always decreasing. It's just the nature of the function. So for this one, we can see we're always increasing. So just like we did with the logs and exponentials, our domain is going to just be what we use down here for increasing. So it'll be x is greater than or equal to -4, or we could use -4 to infinity. And we would never be decreasing here. Okay, try example 2 real quick on your own, because that one is a natural log, and we have done those before. So try that one on your own. Oops, I didn't do that. What's the masculine column? Reese. Almost. Just greater than. Because that's a vertical asymptote right there, you don't want to include the 0. So, almost. And so that would be 0 to infinity if we use interval notation. Good. Okay, let's see who gets to do range. Max. Oh, Delta Math, it knows who's not got it. Anybody want to help him on that one? It is negative infinity to infinity. And logs are tricky because we can see this goes up, 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 up forever, so that should make us think positive infinity. Logs can be tricky because this kind of looks like it has a horizontal asymptote. But when we were doing logs, we learned that logs don't have horizontal asymptotes. They always have vertical asymptotes and no horizontal. So this is going to keep going down forever. Range for natural or any log is always going to be negative infinity to positive infinity. There. All right, so let's see who gets positive. All right, Bronwyn. Okay, so I think I totally get your logic there, but it is not correct. It does include +1. That's one of the things we need to look at. So whenever we're talking about everything except for range, we're given x values, right? So right here, we're looking at this section right here, right? And so that section is going to stop right here at 1. If we think of putting in a vertical line here, I need a different color though, so let's make that orange. Orange too. All right, so if I think of like sectioning that off with vertical lines, right? I've got a horizontal asymptote right here, vertical asymptote right here at 0, and then it goes up to 1. Those are my x values. So it's really easy to say like 1, and then you're thinking infinity, because that goes up forever. But you're not worried about what the y coordinates are doing, other than you need to know they're above the x-axis. We're thinking about x-axis only. So this one would either be, switch back to a pen, 0, less than x less than 1, or you could write it as 0, 1. You don't include either endpoint because you got a vertical asymptote here, right here. This is where it crosses, so you don't want to use one there. Okay, questions? All right, let's see who gets negative. Maddox, it likes you today. Yes, very good. So we'll have x is greater than 1, or with interval notation, 1 to infinity. And I'm just giving you both interval and inequality notation here, because you don't have to give both. You just need to know both, right? So you might see these a lot of times where they're multiple choice, and it might be given either way, so you need to know both of them. All right. Let's see who gets increasing. Noel, where is this graph increasing? Or is it increasing? Okay, it never increases, right? So that one's just none, because it's always decreasing. So let's see who, Summer, what interval would it be decreasing for? Not quite. You want to say because it's always decreasing, you want to say negative infinity to positive infinity. But over here, like at -5, we don't have a graph at all, right? It's not doing anything over there because it doesn't even exist over there. It's 0 to infinity. Because we're only thinking about x values where this is happening. So it's attempting to say negative infinity because it is going down. But we're only talking about x values. So we're thinking about taking like vertical lines, like these orange lines I've got here, and we're trying to like section off the area where it would be decreasing. I'm going to put this over here because it would go, that would be at infinity, right? It'd go on forever. So x values only from 0 to infinity. Or the other way we can write that is x is greater than 0. And so for increasing and decreasing, it's going to be the same as your domain. Okay, questions? All right. Here's a rational. We haven't done a rational yet, so we're going to do this one together. So for this rational, notice I've got a -3 and a +2. So it has been moved to the right 3. So I'm going to put in a line right here and make it dotted blue. That didn't do anything. Let's make that dotted and blue. And then I also have a horizontal asymptote. Here at 2 where I've moved up to. Alright, so For rationals, you're going to have basically just 1 point for your domain and range that you can't use. So the domain, I can do it from the graph. I can say I've got this vertical asymptote at 3. Or I can just look at the equation. So here's another one. I might give you domain for these without a graph. Because whatever's in the denominator we learned yesterday cannot equal 0 because it's going to give you a vertical asymptote, right? So we would say, we can write it a couple ways. We can write it as x does not equal 3. Or we can do negative infinity to 3 and 3 to infinity. If I look at the range, it is also going to just have one spot where I don't have a value. And that's going to be wherever I have my horizontal asymptote, right? Because right here at this horizontal asymptote, my graph is going to get closer and closer and closer to that line in either direction, but it's never going to actually touch that line. So this line is at y equals 2. So we would say y cannot equal 2. Or the other way I can write that is negative infinity to 2 and 2 to infinity. All right, so the last problem where we had to do positive and negative, our point where we crossed the x-axis was perfectly right there on grid lines. This one is not. So, in the event that this happens, and you don't know that number exactly, but you might have to type it in, how could we find that number using our equation? At this point right here, I do not know my x coordinate. I have no idea what it is. But what is my y coordinate? It is 0, right? So in my equation, I could plug in 0 for my y, or in this case, f of x. So 0 equals 1 over x minus 3 plus 2. I need to solve for that x, so the first thing I'm going to do is subtract the 2. So negative 2 equals 1 over x minus 3. Oh, how do I solve an equation when I got that x in the bottom? Multiply. I'm going to multiply by x minus 3 over here, which is just going to cancel that x minus 3. And then I'll multiply by x minus 3 over here. So I'll have negative 2x, if I distribute that 2, plus 6 equals 1. And now I'm down to something that's not so bad to solve. So I'll subtract my 6, negative 2x equals negative 5, and divide by negative 2. So x would equal 5 halves, which would be 2.5. You may not have to do this because it could be multiple choice, in which case I'm probably not going to give you 2.5 and 2.6 or something like that. Probably only one reasonable answer from the graph. Or it might cross perfectly at grid lines where you don't have to do this. But in case you do, you would just plug in 0 for that y. So this point right here, now we have just found that is at 2.5. So this right here is at 2.5. So our function, highlighter, here is above above the x-axis here and everywhere over here. All right. So if I'm thinking about this, always think in terms of vertical lines, sectioning this off. So I would be above the x-axis everywhere over here, right, all the way to negative infinity, up until I get to 2.5. So I'm just going to use interval notation here, I think. Negative infinity to 2.5. And then for this little sliver right here, I'm below the x-axis, so I'm not going to include that for positive. Then I do not include this vertical asymptote right here at 3, but everywhere past 3, all the way over here to the end, I'm also above the x-axis there. So I would say 3 to infinity. Now for negative, I'm below the x-axis just in this little tiny section right here. And remember, we're given x-coordinates. So the x-coordinate right here is 2.5. And then the next x-coordinate right there would be 3. We're using parentheses because we're not including this. Okay, questions so far? All right, and then increasing and decreasing. It doesn't seem like it should be, but these are actually going to be always increasing or always decreasing unless you put a square or something on them. So notice from left to right, we are decreasing here. We decrease down to infinity. Then we have to jump back up here and we start decreasing again, right? So we're decreasing everywhere except for right there at the vertical asymptote where we don't have a graph at all. So we would not increase at all here, but we would decrease from negative infinity up to 3 and 3 to infinity. Or it is okay here just to say you decrease everywhere except 3, so x is not equal 3. Another way to write that. Okay, so I want you guys to try, go ahead and try 4, 5, and 6 right now. I'm going to give you a little while to try 4, 5, and 6. Okay? Very good. Everywhere except for that x equals negative 4. Right? So you could also just say x does not equal negative 4. There. Wonderful. And Braden, where is it decreasing? Nowhere. Okay, questions about that one? All right, let's go to the next one. All right, we've got a square root function here. See, Reese domain. Very good. X is less than or equal to 0. Perfect. If you use interval notation, that would be negative infinity to 0, and we'd have to use a bracket with that 0. Remember, for that, you can also take what's under the square root and set it greater than or equal to 0. But when you have to divide by that negative to get rid of it, what do you have to do to the sign? You got to, I'm sorry, I didn't flip it. You got to flip that inequality sign. So it would make it less than or equal to 0, which is what we said. All right. Okay, Jackson, the range.
I didn't get very far, but I can see that. I think the range goes up infinitely, doesn't it?
It does. What is the lowest it ever reaches?
I think it's 3.
Yes. So we can say that it would be -3 because we're including that point -3. We'll use a bracket and it goes up to infinity. Or we could say x is greater than or equal to -3. Okay. Range is the only time we're thinking about our y values. So you're thinking about where, if I section this off, where's the very lowest. The highest, it keeps on going up here. So it would be at positive infinity. All right. Grace, what about positive? What have you got? Okay. I think you're close. So, negative infinity, I agree with for sure. And then, I don't think it hits exactly right there at 10. Although I haven't checked to make sure, but I don't think it does. So, 10's not a bad guess just looking at the graph. The way that we can find out what that number is exactly is we can do 0 equals the negative square root of x minus 3. So if we plug in 0 for that y, we can find that exact value. So we'll add the 3 to both sides. We'll get 3 equals the square root of negative x. We will square both sides, and we'll get 9 equals negative x. And then we'll divide by that -1. I'm going to tell you, I think my graph is off. Because it definitely does not look like it crosses at 9, does it? Yeah, I don't know. Let me just type this in Desmos real quick. I think that graph is a little off. Well, it looks kind of the same there when you're zoomed out a little bit, but yeah, it should cross at -9 perfectly. I think, because this is counting by ones, right? So -9's right there. I feel like that's off a little bit on that graph. I'm not sure what happened there. So we should have -9 instead of -10. That should be perfectly right there. But given the graph, it was not a bad guess. And probably it's going to be multiple choice, and probably you would not have -10 as an answer choice. So you would probably could figure that out. Okay. All right, Hallie, what about negative? Okay. I agree with the -9, but not the -3. 0. And do I need to include 0 or not? We do include 0 because it includes that endpoint right there. Notice what Hallie did there at first. She said -9 to -3. Why is this not -3? -3 is our y coordinate. We got to give x coordinates for every single thing except for range. But it's really easy to switch over to the, especially when it's on the axis where you're looking at -3, it's really easy to get that wrong. There, so I'm almost glad that you got that wrong in that way so we could point that out. All right, Caitlin, where is this increasing? Very good. That was too easy. Where is it decreasing? Good. There could be some debate on whether or not you should include 0 there at the end, since it's the end point and it's not going past that. But in general, I'm probably going to accept it either way. I wouldn't give you an answer choice with a bracket and without a bracket for that. Now, for negative, I might, because this has certainly got a negative y coordinate right here. It's definitely, so you do have to include 0 for sure. There could be some debate on increase. In calculus, we do this a lot, and my calculus teacher told me for increasing and decreasing to always use parentheses, because at those places either where you're switching or endpoints, it's not doing either one. But a lot of textbooks and other people will say to use brackets sometimes, so I'll accept either one there. Okay? All right. Well, let's move on. Let's see. For this one, Noel, what would our domain be for this graph here? It is almost negative infinity to positive infinity. There is one place we do not have any values, right? And that is at that vertical asymptote. So what we will do is we'll do negative infinity to 2 and 2 to infinity, or we could say x is not equal to. All right, Connor, what's the range for that one? Very good. -2 to positive infinity. Remember, this is the only time you're looking at the y-axis. So the very lowest that it goes is right here at this horizontal asymptote that it has at -2. And then it's all up from there. It's going to go up forever. So it'll be -2 to infinity. All right, Maddox. Delta Math really likes calling me today. When is this going to be positive? Ooh. Yeah, so, this one's kind of bad, and we don't really have time right now. I probably would not give you this one by hand. Well, I might will.
I figured out how to get the second point, but I couldn't figure out how to get the
Yeah. Oh, gosh, I kind of just want to do it and see if I can.
Just that bottom one's for equal to 0.5.
Yeah, so you got 0 equals 1 over x minus 2 squared minus 2. You could add the 2 to both sides. So 2 equals 1 over x minus 2 squared. So if you multiply both sides by x minus 2 squared, if this is confusing to you, don't panic. I'm probably not going to give this one to you where you got to do this. I just want to see if I can do it. So I would divide both sides by 2, which, like Connor said, you got to have that bottom has got to equal, or you got to have it equal to 1/2. How do you get rid of the square? Square root, which actually gives the square root of 1/2. So you got x minus 2 equals the square root of 1/2. And then you would move your 2 over, so you get 2. And when we square both sides, what have we got to do? Plus or minus, there's your other answer you were looking for. And you'll get plus or minus 1/2. I'm probably not going to give that to you where you've got to solve it by hand. Not that you shouldn't be able to do that, because that is something you should be able to do. It's just not my main focus of what we're doing right here, so I don't want to overcomplicate it. So that I would probably either label it for you or let you use Desmos if you saw that. And so we can see, if we just want to use a decimal, it's 1.293. Let's go with that. We are going to be positive from 1.293 to 2. We don't include 2 because we don't have any values at 2. It's a vertical asymptote. and then 2 to our other one here is 2.707. So we're positive from here to the asymptote, and then from the asymptote to that other point of intersection. And then we will be negative from negative infinity up to that point we just found, 1.293, and then from 2.707 to infinity. And then, let's see, Jackson, where is this one increasing?
Using the positive numbers, increasing from
So increasing, always start on the left-hand side when you're talking about increasing or decreasing. So when we start going from the edge over here, you can't really tell what's happening here because it's so flat, but you are increasing. Then here, certainly we're increasing, increasing, increasing. We go up, 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 up forever, but our x values are getting closer and closer and closer to 2, right? So we're increasing till we get to that asymptote. Then after the asymptote, what's the graph doing? It goes back down, so it's decreasing after that. So we're going to be increasing just on this left-hand side of the graph. And so that would be negative infinity up until we get to that vertical asymptote, which has a value of 2. And then we're almost out of time. So decreasing is going to happen from 2 to infinity. And we had a few more that we were going to do, but